Okay, well, sometimes when you have problems, it's better to take baby steps. So figure out what you do know and figure out what you can make it do, and then try to narrow down what it is that's not working. So we took a look at the with the logic analyzer, and the timing signals looked okay. We had that double pulse. That double pulse was me. It was part of my programming. When I incremented the program counter, I also had to have that's a to device. I also had to have a from device. It didn't matter what the from device was because it wasn't going to be used, so I just reused the program counter. So it was okay to get that double program count. The way the program is set up now, it's reading the program counter and sending it to the I/O device, and then incrementing the program counter, and then repeating that. So I don't have the program counter in there, so it's trying to read from something. So it's pulsing the PC read. That's this line here. So I rerouted the PC read to the I/O switches. So instead of reading the program counter, it reads the switches. So it reads the switches and puts them on the I/O. So it's just going back and forth here. And when I flip the switches, sure enough, the I/O changes. And we can see it getting asserted onto the bus. And yeah, so everything is working. So definitely the I/O is working, the bus is working, the program is actually doing what it's supposed to be doing. So we've confirmed all of that now. So the next step is to put the program counter back in and see if we can get the program counter to do two things. Increment, which it was before. So the increments didn't seem to be the problem, but for some reason it wasn't putting the program counter onto the bus, or it was counting funny. It was doing something really weird last time. So I've taken off all the other circuitry that we're not using, so that's not going to be in the way. So we'll put the, this is actually the ROM RAM, we'll put the program counter back on, which I've taken away and put someplace. I have to find it. We'll put the program counter back on and see if we can't get it to do what we're doing here, which is read from something and write to something. We will read the program counter and we will write it, and then hopefully the program counter will also increment. Alright, so we're still running the program, have the program counter. It's going to read the program counter and put it into the I/O, and then it's going to increment. And that's what this line is, the PC increment. So if I hook up the increment, you can see it starts to count. But it's not counting every number. So it's like missing a pulse. If I use the clock from over here, which is just a single square wave, and I hook that up, then you can see that we are counting just fine. 4, 5, 6, 7, 8, 9, A. So it works great with an external square wave, but it's not working with this signal. This signal is a single pulse, but it's a negative going pulse. And it has a long high time. And I'm thinking I probably need the other thing around. I need a low with a rising edge. So I need to invert this line, I believe, which is not going to be too easy to do, I believe. I do have an inverter, and I'm not using, I think, all of the pins on the inverter, so I might be able to route that over to the inverter. So we'll have to take a look at the schematic and see if I can invert that and turn things around. I need to look at the schematic or the data sheet of the 163 counter. I thought that all I needed was a positive edge, and it really didn't really matter what the state of the clock line was after that edge. But it just doesn't seem to like to work with this pulse. So. Unless it's coming at a funny time, I'm reusing a signal. No, I'm not. I don't know. Yeah, so I need to see if I invert this line. Maybe I can do it over here maybe I'll run this line over here and invert it and bring it back just to see if that inversion makes it work better. That's probably a better thing to do. I'll do that. I'll wire up a little inverter over here and see if that fixes things. But using a just using a clock seems to give me all the counts. So I don't know what's going on. Now it's, well, I don't know. Okay, well, I was going to invert the PC increment. Instead of having a low going pulse, have a high going pulse. But then I remembered that I already have some signals that have an inverter on them, such as anything that has a latch on it, like a 573. So the A-write, register A-write signal on the microcode machine is a positive going pulse. So I rewrote the code. Instead of pulsing the PC increment, I'm pulsing the A-write. And you can see over here, I have it going, turn this one off, I have it going into this LED here. So you can see that it is a positive going pulse. It's mostly low and then it pulses high once in a while. So we will use that signal instead to clock the PC increment. So let me pull this over here and put it here. And you can see that we're still getting a double pulse. We have a single pulse, but we're getting a double count. You can see here it goes E0, 2, 4. So it's counting twice on a single pulse. It doesn't matter if that pulse is low going or that pulse is high going. So that's a definitely good clue. And again, I don't know why when I put a square wave into it, external, it works just fine. But there must be an erase condition or some type of edges or something. So I need to take a harder look at how this chip is actually functioning. Here I'm floating the increment, so it counts really fast. Yeah, it's very interesting. I can watch the bus get asserted down here, and it is counting 1, 3, 5. So it counts twice and then asserts the bus. So there's a double pulse that's happening on this PC program counter board. So you take a look at that.